Hello students, in the previous lecture we have seen some numericals on the real numbers, and in this lecture we have seen your 1.1 fourth example is use Euclid's division lemma to show that the cube, here cube is present, and your third example square is present, but here cube is present, of any positive integers is of the form 9m plus 1 or 9m plus 8. But in third example, your hint is what? You will write, your hint is what? First, again you will see, let x be the any positive integer that is in the form 3q plus 1 and 3q plus 2. Then you will write here, let us consider an arbitrary positive integer x such that it is in the form 3q plus 1 and 3q plus 2. This is your rule. Then here cube is present, then you will take here cube. Which type? Suppose first your condition is x equal to first 3q. Then cube on both sides we get, cube on both sides we get, that is x cube equal to 3q whole bracket cube. Then x cube equal to this 3 cube is what? 3 into 3 into 3, that is 27. Then you will write here 27q cube. But here 9m is present, then you will split up in this form, that is 9 into 3 cube. And here you will write but m equal to 3q, means you will write here 3q cube equal to m, then you will write here m, then you will get 9m, that is x cube equal to 9m. This is your first condition. Your second condition is what? 9m plus 1. Then again you will write 3q plus 1. Again you will write your second condition is 3q plus 1. Again the same rule you can apply. Cube on both sides. Cube on both sides we get, that is x cube equal to 3q plus 1 whole bracket cube. And here you will use which formula? A plus b whole bracket cube. Then your formula, first you will write your formula, that is a plus b whole bracket cube equal to a cube plus b cube plus 3a square b plus 3ab square. And you will put a equal to 3q and b equal to 1. Then put in this formula this values, that is you will get here a cube, that is 3q whole bracket cube, plus b cube, that is 1 cube, plus 3 a square, that is 3q whole bracket square into 1, then 3a, that is 3q into 1 square, means you will put only the values a equal to 3q and b equal to 1. And then 3 cube is 27, q cube is q cube, 1 cube is 1 plus 3 into 3 square is 9 q square plus 1 plus 3 3s are 9 cube into 1 square is 1. Then 27 cube plus 1 plus 9 3s are 27 q square plus into 1. Then you will write the same value, that is 3 9s are 27 q square, and here 9q into 1, that is 9q. Then rearrange this term. Which type you can rearrange? First you will write the q cube, and second you will write the q square term, third you will write the q term, and last is 1. Means q cube, q square and cube, and last is the constant. And here your common term is what? Here 9m plus 1, then you will take here common 9. Then 9 is common, then you will get here 9 3s are 27 plus 9 3s are 27 plus 9 1s are 9 and plus 1. Then again you will write here what? 3q cube plus 3q square plus q equal to m. Then you will put here m. Then you will get the value that is 9m plus 1. This is your next value. X cube equal to 9m plus 1. And your last value is what? 9m plus 8. And you will take here which form? 3q plus 2. Same type. Then write the next condition. Third condition. Your third condition is x equal to 3q plus 2. Then again cube on both sides. We get cube on both sides. We get. Then you will write here x cube equal to 3q plus 2 whole bracket square. Again you will use which formula? A cube plus b cube. That is here a cube plus b cube plus 3a square b plus 3ab square. Again you will write the formula. That is a plus b whole bracket cube equal to a cube plus b cube plus 3a square b plus 3ab square. And you will put in a place 3 cube and in b place you will put 2 and then solve. Then a cube, that is what? 3q whole bracket cube plus b cube, that is what? 2 cube plus 3a square. A means 3q whole bracket square and b means 2 plus 3ab square. Then 3a means 3q and b square means 2 square. Means you will put only the values and then solve. Then equal to 3 cube, that is 27q cube plus 8 plus 3 into 3 square is 9q square into 2 plus here 3 3s are 9q into 2 square is 4. Into 2 square is 4. Then here equal to x cube equal to 27q cube plus 8 plus 3 9s are 27, 27 2s are 54q square, 54q square. Then here plus 9 4s are 36 plus 36q. Again you will check here 3 3s are 9 and 2 square is 4, then 36, 9 4s are 36 cube. Then rearrange. Then 27 cube plus 54 q square plus 36 q plus 8. Then again you will take here common 9. Then you will take here 9 common. Then 9 3s are 27, 9 6s are 54, 9 4s are 36. And plus 8 and here you write but 3q cube plus 6q square plus 4q equal to m. Then you will write here m, that is 9m plus 8. This is your third condition. This is your third condition. Means 9m plus 1 and third is 9m plus 8. Then from 1, 2 and 3. From 1, 2 and 3 we get the cube of any positive integer is of the form 9m plus 1 or 9m plus 8. Here you will write the complete sentence. We get the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. And this is your question. Then see the next example. Sorry, this is your fifth example. This is your Fifth example, use Euclid's lamp. Then in your book, theorem 1.2 on page number 8, fundamental theorem of arithmetic. Every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factor occur. And the examples are here. First you will see the one formula. First you will see the formula. HCF A comma B into LCM A comma B equal to A into B. This is your formula. Means HCF into LCM equal to A into B. A into B, A is any number and B is also B is also a second number. This is your formula. Then 1.2, your question 1 is express each number has a product of its prime factors. Your first example is 140, your second example is 156, your third example is 3825, your fourth example is 5005, and your fifth example is 7429. Here all the examples are same. Then write here 140. Here 114 is 0 is last digit, then you will divide by 2. Then 2 sevens are 14 and 0. 2 sevens are 14 and 0. 2 sevens are 14 and here 0, that is 70. This is your first prime number. Then second you will divide. Again you will divide 2 because here 0 is present, then 2 3s are 6 and 2 5s are 10. Again you will write here 2, then 70, 2 3s are 6, then here 2 5s are 10. Then you will write here 35. Your second prime factorization is 2. Again you will divide. Here 3 is not correct, 4 is not correct, then 5. 5 7s are 35, and 5 is a prime number, also 7 is a prime number. Means here this prime factors are completed, and you will write here 140 equal to 2 into 2 into 5 into 7, and this is your answer. You will write in this type also 2 7s are 40, then 0, 2 3s are 6, then 5, 2 5s are 10, then 5 7s are 35, then 7 1s are 7. 2 2 5 7, they are same method. This is called the tree method. Then the fifth examples. This is your first example, then next fifth example 500. Again same type you can factorize. Then 5005. Here 3 is not correct, 2 is also not correct. Here 5, then 5 1s are 5 0 0 5 1s are 5, because you will divide it by 5. Means you will divide it by 5 0 0 5. Means 5 0 0 5 divide 5, then you will get 0. And which quotient is present here? 1 0 0 1. Again you will divide here 7 1 0 0 1. 7 1s are 7, then 3, 7 4s are 28, then here 2, 7 3s are 21, then here remainder is 0 and your question is 1 4 3. Again, this is your first prime factor, this is your second. Again, 1 4 3, you will divide 11, 11 1s are 11, then 3 is present here, 11 3s are 33, and your next factorization is 11 13s are, and 13 is a prime number. Means your prime factorizations are 5 0 0 5, then 5 prime factors are 5 into 7 into 11 into 13. This is your answer. This is your answer, and this is your question first in 1.2, and all examples are same. You can do in this type. Then see the next example. Find the LCM and HCF. Find the LCM and HCF of the following pairs of integers. Of the following pairs of integers, and verify that LCM into HCF equal to product of the two numbers. Product of the two numbers. Product of the two numbers means one number is A, second number is B. Then you will write the same formula, that is LCM A comma B into HCF A comma B equal to A into B. And your questions are 26 and 91. The second question is 510 and 92. Your third question is 336 and 54. See. Then first example, 336 and 54, correct, and 26 and 91. Then your first example. What is your question? Find the LCM and HCF. Please first we will find the LCM and HCF of the following pairs of integers and verify that. First we will find HCF, then LCM, and then verify LCM into HCF equal to product of two numbers. Product of two numbers means these two numbers are given in your example. Then you will take your first example, that is 26 and 91. 26 and 91. Then first you will prime factors, means you will do its prime factor, that is 2, 2 1s are 2, 2 3s are 6, and 13 is a prime number. Then you will write 26 equal to what? 2 into 30. Here you will write 91. Here 3 3s are 9, but 1 is remainder, then this is not correct. Then 7. 7 1s are 7, then 2 is remainder, then 7 3s are 21, and here also 13 is a prime number. Then you will write 91 equal to 7 into 30. Then first you will see its HCF. HCF means what? In these two numbers, which common factor is present? This 13 common factor is present. Then your HCF is 13. Then your HCF is 13, because 2 is present here but 2 is present here, no. This 7 is present here but 7 is present here, no. Only 13 will be present in these two numbers. Then you will take here only a common term, then HCF is 13. Then LCM. Here, which are the different number? 2, 13 and 7. They are the different number. Here 13 is present and 13 is repeated. Then you can write only one time. Then 2 into 13 into 7. Here 13 is present, here 13 is present, but here 1 power, here also 1 power, then you will take here 1 power because all are 1 power, then 2 into 13 into 7. Here multiply, then you will get 2 into 13 sevens are 91. 13 sevens are 91. Again you will write here 2 ones are 2, 9 twos are 18, that is 182. Means your LCM is 182. 182. Then verify that is you will write here verification. Your answer is correct or not, then you will write here verification. Then LCM into SCM. This is your LHS side. You will see here your LHS side is what? LCM into SCM and equal to product of the two numbers. Product of the two numbers means these two numbers you will multiply, then you will get the answer, and also LCM in SCM they are multiplied, then you will get the answer. They are equal, then your verification means they are equal, then your formula is correct. Then LCM into SCM. Then what is your SCM? 30. And what is your LCM? LCM is 182. Then your first LCM, then you will write 182 into 30. Then 182 into 30, you will multiply. 3 2s are 6, 8 3s are 24, then 2, 3 1s are 3, then 5, then here 0, 2 1s are 2, 8 1s are 8, and 1 1s are 1, then 6, 6, then here 13, here 2, then you will get 2 3 6 6. 2 3 6 6. And your RHS side is what? Product of the two numbers. Product of the two numbers means which two numbers? 26 and 91. Then you will multiply 26 multiplied by 91. Then you will get which number? 6 1s are 6, 2 1s are 2, 9 6 are. Here 0 is present, 9 6 are 54, then 5, 9 2s are 18, 18 plus 5 is 23, then 6, then 6, then 3, then 2. Here also your answer is 2366. Means this number and this number they are same, means your LHS equal to RHS. And you will write the formula is what? LCM into HCF equal to product of two numbers. Product of two numbers. LCM into HCF equal to product of two numbers. Correct? Then your second example is, then you can do your second example. Then you will see your third example. Second example you can do. The third example, that is 336 and 54. The second is also same. Then 336. Then again you will divide 2. Then 2 ones are 2, 2 6s are 12, 2 8s are 16. Same type you can do. Same 336. Then 2 1s are 2. Then here 1. 2 6s are 12, then 1, then 2 8s are 16, then you will get 0, then you will write here 2 into 168. Again you will divide 2. 2 8s are 16, 2 4s are 8. 2 8s are 16, 2 4s are 8. Again you will do here 168 divide by 2, 2 8s are 16, 0, 2 4s are 8. Then your remainder is 0. Then you will write here 2 into 84. Again same condition. 2 4s are 8. 2 2s are 4. Then 2 2s are 4, then 2 ones are here 3, 7s are 21, and 7 is a prime number, means your prime factors are 2, 2, 2, 3, 7. They are your prime factors. Then you will write here 3, 3, 6 equal to how many times? 2, 4 times. Then 2 into 2 into 2 into 2 into 3 into 7 is 2 raised to 4 into 3 into 7. Then 54. 54. Again you will divide 2. Then 54 divided 2, that is 2 2s are 4, 2 7s are 40. Again 3 9s are 27, 3 3s are 9, and 3 is a prime number. Then 2, 3, 3, 3. They are your prime factors. Means 54 equal to 2, 3, 3, 3. And again you will write 2 into 3 cube. Again you will write 2 into 3 cube. Then first you will find its HCF. Then HCF is what? Common factor is called the HCF. Here 2 is present, here 2 is present. See here, 2 is present, 2 is present. Then 2 is a common. Then you will write first 2. Here 2 is present, but here 2 is not present. Here 2 is present, but here also not. 2 is not present. But here 3 is present, here 3 is present. Then your second common factor is what? 3. And here 7 is present, but here 7 is not present. Then you don't write. Then your HCF is what? 6. HCF is what? 6. 2 into 3 is 6. Then your LCM. LCM. Then LCM is here. Which are the different numbers are present? Here 2 is present, here 3 is present, here 7 is present. But in 2, which is the highest power? 4 is the highest power. You will compare to this number and this number. Then here 2 raised to 4 is present, here 2 is present, then you will write here 2 raised to 4. Here 3 is present, then you will write, here 3 is present, here 3 cube is present, then you will write 3 cube. Means in LCM you will take its higher power. And 7 is only 1. Then 2 raised to 4 is 16 into 3 raised to 9 is 27 into 7. 2 raised to 4 is 16 into 3 raised to 3 is 27 into 7. Again you will multiply that here 16 into 7, 49. Then 4 is the remainder. Then 7 2s are 14. Then 4, that is 189. Then 189 into 16. Then 9 6 are 54. Then 5. 8 6 are 48. 48 plus 5, that is 53. 48 plus 5, that is 53. Then 6 1s are 6. Again you will see 9 6 are 54. Then 5. So 6 4s are 48. 48 plus 5, that is 53. Then 5 is remainder here. Then 6 1s are 6. 6 plus 5 is 11. Then here 0. 1 9 1s are 9. 8 1s are 8. 1 1s are 1. Then 4. Then 12. Then 1. 9 plus 8 9. 8 plus 1 9. Then 10. Then 1. Then 3024. Here your answer is 3024. This is your LCM. This is your LCM. Your LCM is what? 3024. Then verification. Then your LHS is what? LCM into HCF. Then LCM is 3024 multiplied by HCF is 6. Then multiply here 3024 into 6. 6 4s are 24. Then 2 6 2s are 12. 12 plus 2 is 14. Then 1 6 zeros are 0. Then 1 6 3s are 18. That is 18144. This is your LHS. Then RHS. Product of two numbers. Product of two numbers. Then product of two numbers are A into B. A into B means 336 into 54. Again you will see here 336 into 54. Then you will multiply 336 into 54. 336 into 54. 6 4s are 24, then 2 6 4 3s are 12, then 14, then 1 4 3s are 12, then 1 13, then 0 5 6 are 30, then 3 5 3s are 15, 15 plus 3 is 18, then 1 5 3s are 15, then 1 16, that is 4 4 8 plus 3 11, then 1 6 7 8, then 1, then also here 1 8 1 4 4 is taken. In this answer and this answer they are same, means here you will write directly LHS equal to RHS, and your formula is also correct, that is LCM into SCM equal to product of two numbers, equal to product of two numbers. Then here your second question means 1.2, in 1.2 your second question is completed, and at the rest we will see in the next lecture.